Hello there, this once again is Mr. Spinks, and we are now in section 2.2 of NAMS, the first video of 2.2. It's about sets, but now we're going to be classifying types of sets. Things called subsets, proper subsets, talking about a lot of subset ideas here. So let's start here by defining what a subset is. That'll make life quite a bit easier. So starting over here on what a subset is. Right, we'll use it in an example. Set A is a subset of set B if and only if all of the elements of set A are elements of set B. Take my example over here. It says set A is blue, green, orange, and red. Set B is just red and orange. Notice how all of the elements of set B are in set A. And therefore, in this case, we cannot say that A is a subset of B, because all of the elements of A aren't in B, but we can say that B is a subset of A. Now, here's how we write that. B is a subset. Here's your symbol for subset. The C with the line under it of A. And we can also say not a subset. A is not a subset, so there's subset with a line through it. That's not a subset of B in this particular case. Because once again, all the elements of A aren't in B, but all the elements of B are in A. Give an example of a set and a subset of that set. All right, well, if we had set C is going to be 1, 2, 3, 4, and 5. If we wanted a set that was a subset of that set, let's call it set X. Well, set X has got to have all elements that are in set C. So as long as I pick elements of set C, I'm okay. Well, I'm going to pick 2 and 5. Notice here, all of the elements of set X are in set C. Therefore, we can say that X is a subset of set C. That's how we do that. That's the idea of subsets. Looking here, we have set A, which has apples, bananas, grapes, cherries, oranges, and watermelons. It says, is B, apple, grape, orange, a subset of A? So you're going to look and see, is apple, grape, and orange in set A? I'm looking, I see apple, I see grape, I see orange. Therefore, since all of the elements of B are in A, yes. B is a subset of A. We'll look down at the next one. The next one says, is cherry, watermelon, and kiwi a subset of A? So I'm going to look, are all these in set A? Well, cherry is, watermelon is, but I don't see kiwi up here in A. And the fact that there was even one element that is not in the other set means that this is not a subset. Finally, list a subset A that is different than the ones above. Well, okay, I'm going to start with A equals, and I'm just going to list some that are up there. All right, let's go with apple, and we'll go with grape. Once again, doesn't matter how many I choose, just as long as the ones that I choose are in subset A, I have created, or are in set A, I've created a subset. So once again, notice here, apple and grape are in set A above there. That's why it's a subset. Moving on, we're going to talk about proper subset now. So, in talking about proper subset, once again an example, if set A is a subset of set B, but set A does not equal. They are proper subsets. So what's that mean? That means they're not the same. They have the same elements, but they're not the same. So let's use a couple of examples here. We have sets A, B, and C. All right. Well, set A is going to be 1, 2, and 3. Set B is going to be 2 and 3, and set C is going to be 1, 2, and 3. Well, I can say that A is a subset of C, because all of the elements of A are in C. I can also say that C is a subset of A in this case. That's legal. That's just subset. All the elements are in there. I can also say that B is a subset of A, and B is also a subset of C. Because notice 2 and 3 are in A and C, but we're talking about proper subset here. So proper subset is noted with not just this, with no line under it, just the C. So let's talk proper subset. Well, if we talk proper subset, B is still a proper subset. There's proper subset right there of A, because they're not equal and all the elements of B are in A. B is also a proper subset of C, because all the elements of B are in C and they're not equal, but you absolutely cannot say here that A is a proper subset of C, because this time they're equal, therefore can't be proper. So that's the idea of proper. They're subsets, but they're not equal. And we'll create one more example here to make this work. We have universal set, which is 1, 2, 3, 4, 5, and 6. Now, we have set A. Set A is 1, 3, 2, 4, 5, and 6. And we have set B. Set B is 1 and 2. Clearly, you notice here that B is a proper subset of U. It is also a subset of U. However, A, while it is a subset of U, cannot be considered a proper subset of U because they are equal to one another.